All right, Pre-Cal 30 class, we are going to go through example 1.3.2, combination of transformations. Show the combination of transformations that should be applied to the graph of the function f of x is equal to x squared in order to obtain the graph of this transformed function. G of x is equal to this. Write the corresponding equation for g of x. Well, let's go through this transformation. First off, we're going to highlight the parts of the transformation that deal with vertical issues. So this 1/2 is a vertical, and this +1 is a vertical. The 1/2 is going to be a vertical stretch. So we're going to take our y value and we're going to times it by that. All right, remember with the vertical stretches, because they're on this side of the equation, they're on this side of the equation away from our y, we do what they say. It's 1/2 times this. So we multiply y by 1/2. This +1 here, this is a vertical shift. And because the vertical shift is not attached to, this is the y value here, it's not attached to that, we do what it says. We're going to do +1 to our y values. Okay, so over here, if we start with f of x is equal to x squared, that is going to be an x and a y. Right, that's going to give us our points, x and y. We can list some key points. I'm just going to list a couple of them. -2 + 4, 0, 0. Here's 3 of them. This is a parabola. In our new one, it is going to come over and we are going to get 1/2 y + 1. Now, when we look here, this is a horizontal stretch. That's a horizontal stretch. And because it's with the x value, we do the opposite. We're going to divide by 2, which is the same, or times by 1/2. Same thing, this is a horizontal shift. And we do the opposite. Negative means right 4, or +4. So for our x values, we are going to do 1/2 of x, or x divided by 2, plus 4. So there is going to be our transformation mapping. Now, if we take a look at a couple of these points, -2 and 4. So 1/2 times -2 is -1. -1 plus 4 is +3. Then 1/2 of 4 is 2. 2 plus 1 is +3. 0 is going to be at +4 plus 1. And 2 comma 4 is going to go to 2, 6. And 1/2 of 4 is 2, so that's 3. Now what this function will look like, this function will look like this. G of x is going to equal to 1/2 brackets 2 x minus 4 brackets squared. So this whole section here gets dropped in for x. So right here, that's where x was. That's this whole section here. And then we're going to +1 on it. Now, how you can check this is you go to Desmos, and we type in y equals x squared. I can't do Desmos on the screen record, otherwise it'll stop screen recording for me. Then I type in my new one that I wrote out, 1/2 brackets 2 times x minus 4 brackets. I square that. I go +1, and I check my points. My vertex is at 4, 1. That's good. And I just check x equals 3. At x equals 3, it's 3. That's good. I move x over to 6. And when x is at 6, it's at 9. I know why. I found an error. This here, 2, when I put that in here, half of 2 is 1. 1 plus 4 is 5, so it should be 5, 3. So it's always important to check over your graph. This is 5, 3. And I do that, and it checks out. All right, so that's how you read these transformations. There was no flips in this one. There were no reflections. So if we look in here, if this was a -2, then there would be a flip. Or if this was a -1/2, there would be a flip. So because both this and this were positive, there were no flips. This would flip it in the y-axis, so horizontal flip. A negative here would flip it in the x-axis. It's a vertical flip. All right?